The cup of a wine glass has a shape formed by rotating the parabola about the y-axis. Its upper rim is a circle of radius 1. How much wine does it hold? Let's draw the figure. Here is the x-axis, here is the y-axis. The parabola looks something like that. And the parabola is bounded by the upper rim with radius 1. So it's over here where x is equal to 1 and y is also equal to 1, since 1 is equal to x squared. This is our radius. We need to calculate the volume of the glass. That is actually the volume that's a consequence of a rotation of this part of parabola where x is greater than when equal to 0 about the y-axis. So there are two ways to do this. One way is to consider the unit volume as a disk that is formed by the rotation of a single point of the curve. So this disk looks a bit like this. It's very thin and its radius is equal to x. Its thickness is delta y. So we have a disk with radius x and height delta y. If we consider this as a unit volume, then the unit volume is equal to the area of the circle, which is the base of this disk, x squared times pi, times the height, which is equal to dy as x tends to 0. So this is an infinitesimal volume. However, we need to transform dy into dx, and in this case we have x squared times pi times d of x squared, that is 2x to the power of 3 times pi times dx. We obtain the full volume by integrating the volume dv from x is equal to 0 to x is equal to 1. That is the integral of 2 times x to the power of 3 times pi times dx from 0 to 1. We place 2 pi in front of the integral. We integrate x to the power of 3 dx, and we obtain 2 pi over 4 times x to the power of 4, where the bounds are 0 and 1, which is equal to pi over 2. Another way to solve this is to consider a different unit volume. In this case, unit volume is going to be a shell of a cylinder. So let's take this shape one more time and consider it as a cylinder. And we have another cylinder within. A smaller one. And in this case, our unit volume is not going to be the volume of any of those cylinders, but their difference, volume of a shell between those two cylinders. So there's part of the shell outside and part of the shell there on the back. So if we take a look at this volume, the volume we can call delta V is the difference of volumes occupied by two cylinders. V2 minus V1, where V2 is equal to R2 squared times pi times height h, and volume V1 is equal to R1 squared times pi times height h. So this is R2 squared minus R1 squared times pi times h. And if we mark the difference between squared radii of the cylinders as delta R squared, that is delta of R squared, then we can write this down as delta R squared times pi times h. As we let our delta R actually go to 0, take a limit, and we get a unit volume dV is equal to d R squared times pi times h. The differential of R squared is equal to 2R. That is 2R pi h dr. In our case, R is once again equal to x. H, in this case, is equal to y. So this is 2 times x times y times pi times dx. As x is R and y is h. Therefore, our full volume is equal to the integral of the volume where x once again goes from 0 to 1 of the unit volume, and that is the integral of 2 times x times y times pi from 0 to 1. Y is equal to x squared, so this is the integral of 2 pi, which we can place outside of the integral. We have x times x squared, that is x to the power of 3 dx. So this is 2 pi over 4 times x to the power of 4, where x goes from 0 to 1, which is equal to pi over 2. We obtain the same results with a bit different method.